Hi guys, welcome back to our time series classical multiplicative model lecture series. We are now moving on from the seasonal component estimation to the trend component estimation, and then on to actually making our forecasts. So a quick recap: we started with this time series data. We smoothed it out, noticing seasonality in the data and looking at the plot. Then we extracted the seasonal irregular component, averaged out the irregular component, and we're left with the seasonal components. Now we can focus on the trend component. So first thing we need to do is what's called deseasonalize the data. So I deseasonalize. In other words, I take the seasonality. Now that I have the seasonality, let me remove it from Y. Since this is a multiplicative model, that removing process is the opposite of multiplication. So we're going to divide y by s. If we were doing an additive model, we would subtract s from y. Okay, so this is another simple calculation here. So we got y divided by s, and we're just going to do that for all our time series data. And this, what we're looking at, is officially, finally, our deseasonalized data. Seasonality has been taken out of the original time series, where we noticed this repeating cycle of up and down movements in the time series data. Okay, it's a nice point here to actually view what's gone on. So I'm going to insert a new chart. Adding a line to a chart in Google Sheets is sometimes doesn't give me the results I like. So I just deleted my original plot we created, and I'm going to make a new one. It's quick enough. So I'm going to insert chart. I'm going to go over to chart types. I'm going to just try to start from scratch. So I'm going to delete whatever they suggested. I'm going to highlight the time series data. I'm going to add another range. I'm going to highlight the deseasonalized data. And hit OK. Select a line chart. And sometimes, yeah, here we go. It took a second to update. Okay, good suggestion. Now maybe I want to just remove this title. It is a bit lengthy. Okay, I don't even need a title. I have a nice legend here, so it lets me know what I'm looking at. So let's take a look at this. This is quite informative. Basically, this is a visual on everything we've done so far. So we see the blue line is clearly Y. That's the time series data. I don't know why it's calling it 4.8. That's the first value, I guess. So the blue line is the original time series data before we did anything to it. Our first aim was to smooth it out, to kind of level those peaks and lift those valleys, right? So look at the red line. After the smoothing process and this extraction of the seasonality, and then removing the seasonality and getting finally the red line, the deseasonalized data, we see how much smoother that is than the original blue line, the original Y variable, the time series data that we started with. The reason why we wanted to do this is now we can focus on the trend. Now, having removed these peaks and valleys, the seasonality in essence, we can focus on estimating the trend. We know it's a slightly upward trend. It's kind of now even more clear. But now we can focus on actually getting an equation for the line that kind of summarizes this trend, which is going to be pretty close to this red line here. So to estimate the trend component, let me actually, you know what, I'm going to go ahead and delete that for now. We're not going to need that. I am going to do that in this column. So how are we going to do this? Well, we're going to treat the values of the deseasonalized data, that red line we were just looking at, as our y variable and t as our x variable in a simple linear regression. Now, you recall from simple linear regression that y hat equals b0 plus b1 times x, which said that y is linearly related to x, or in other words, y is a linear combination of x. In this case, there's only one x, so it's just has a linear function of x. So how to get this? This is just a line, right? Mx plus b, if you're more used to this. This is the slope of this line, and this is the intercept of this line. So how to get these values? That's what simple linear regression will give us. The least squares regression line will give us estimates for the intercept and the slope. And so once we have these, we will be able to estimate the trend component. Except here, we're going to be estimating the trend component using, this is a 0, t, which is the time code, as our x. Okay, so see the parallels between these two equations. In this context, this is how we're applying simple linear regression. Okay. To do this, we're going to need Excel Miner. So we're going to go Add-ons, Excel Miner Analysis Toolpack Start. If you don't have this, you need to go to Get Add-ons and get Excel Miner before you can run this. Okay, so Add-ons, Excel Miner, Start. Once this loads, we need to scroll down and find linear regression. Our y variable is going to be our deseasonalized data. Our x is going to be the time code that we created. We're going to only go up to the data that we have. Okay, we're not going into the future yet. We're going to check the labels, make sure that these guys are correct. It's a bit clunky. It's not as smooth as software that lives on your local drive. This is live online. Uncheck the confidence interval. We don't need this. We need to specify where we want this. I would recommend you select an output range that is far below, somewhere away from all the work that we're doing here. And that's all we need. We click OK once we know we got the inputs correct. And we could close this out and we could take a look at some of the output here. There were 16 observations, right? Because there were 16 time periods. That's not a surprise. Okay. Some of these other things, if you've taken my course, you know what they mean. R-square, adjusted R-square. What we're really interested in here are the regression coefficients. That is the B0 and B1 that makes up the equation we're going to use to estimate the trend component. B0 plus B1 times time. And so T hat here equals 5.10, if I round to 2 that is, plus, indicating a positive trend, 0.15, which is B1, right? There's B0, times T. This guy I'm going to take back up with me to the column I've labeled trend, and I'm going to use this equation to estimate the trend component for all of my time periods, including extrapolating this into the future, into the 2015 quarters that I'm trying to predict. So I'm taking this guy up into this column here. Okay. So how do I do this? Equals. I can type 5.10, but I'm rounding there. Why not say equals and then go back down, click on 5.10. Plus, I could type 0.15, exactly how I wrote it out before by hand, or I could just click on this, right? Times T. Well, what's T in this row, the first row I'm in? T is 1. I could type 1, but much more intelligent is to click on 1. Okay? Now if I hit enter, I actually just plugged in 1 into that equation. 5.10 plus 0.15 times t. I plugged in 1 there, and I got the estimated trend component for time period 1. I plug in 2, I'll get it for period 2. I plug in 16, I'll get it for period 16. So all I need to do is basically drag this formula down. So before I drag it down, I need to kind of actually lock those coefficients. So let me do this formula again quickly. Equals B0. I'm going to hit F4 on my keyboard. That's going to make that an absolute reference so it doesn't change. Plus B1, hit F4 on my keyboard. That makes it an absolute reference so it doesn't change when I drag this down. Times, since I'm in row 1, my time code is this guy, 1. I don't want to hit F4 there because I want this to change when I drag this formula down. So what do I mean by drag down? This is what I mean. So I don't need to type this more than once, because if I type it correctly in the first row, I can just drag it down all the way to the last time period that I have data for, and extrapolate now into the future year that I want to predict. So now I have the trend components for all the quarters of 2015 as well. Okay, so I took what I learned from the past and I projected it into the future as far as the trend. I did the same, if you recall, with seasonality. Irregularity was averaged away, and if you recall our formula for the the multiplicative model, y equals seasonal component times trend component times irregular component. I averaged this guy away. We saw that process in the previous video. I estimated this guy and this guy. Now all I need to do is multiply these two together to get predictions for the time series value. Excuse me. So my last column here will be predictions / forecasts. Okay, and this is where we've been trying to get to the whole time, from the very first to the very last. This was our goal. Okay, so let me resize some of this stuff. Okay, all I do here is I multiply S times T, and I will get my forecast. So equals S times T. I'm clicking on the cells while I'm saying S times T, right? So my prediction for 2011 quarter 1, in other words, time period 1, is 4.89. Actual time series value for quarter 1, 2011, time period 1 was 4.8. So it seems like it's doing a pretty decent job of making this prediction. So let's look at more. Obviously, we could drag this down, of course, all the way to time period 16 comfortably. These are predictions for the time series, and we know exactly what the time series values were for those periods. Okay, so I can, at this point, I can just kind of look at these and see how well things have gone. But obviously the goal of all this was to not just to predict values for periods that have already happened and I already know the values for, but to take these into the future where I don't know the values for y. So I continue dragging this down and I get predictions finally. So these 4 numbers, let me format this a bit. These 4 numbers represent, let me bold, predictions for 2015 for this time series. So if this was sales, we predict sales to be 7.09 million, thousand, whatever this might be, for 2015 quarter 1, 6.49 for quarter 2, 8.63 for quarter 3, 9.19 for quarter 4. These guys are our predictions. This was the goal of our whole activity from the very beginning. Okay, of course there was a lot of steps to get here. And one way to visualize this now is to make a sequence of those plots. So I'm going to plot this guy, the original time series data, and the forecast together on one plot. I'm even going to include deseasonalize so we can kind of see where see the sequence of steps we've took. Okay, so let's insert a plot chart. We're gonna select the data. Let's select a few ranges here. Let's pull this aside. First off, the original time series data. Second off, the deseasonalized data. Finally, and I hope this works well because we're going to go into new periods. And we're going to choose a line chart. Yes, perfect. It looks beautiful. It made a legend for us. Insert this. And let's take a look at let's take a visual look at what we've done with all these videos in this all this process. Okay, so the blue line, if you can see it, is the original time series data. It obviously stops at a certain point. This is 2014 quarter 4, right? And this was obviously the beginning, 2011 quarter 1. The red line we saw as well, this was the deseasonalized data. This was a step along the way in our forecasting method. And we talked about this smoothed out the original time series. It also stops, obviously, at quarter 4, 2014. But what goes into the future, obviously, is only the predicted and forecasted, rather, values. Those values that we just talked about. So you see the orange line starts all the way back in 2011 quarter 1, really nicely almost traces to perfection the original time series data, the blue line. And then at some point, not some point, well, very, very clearly, in 2014 quarter 4, time series, the historical data is over, right? That's the latest data that we have, the most recent. And all we can do now is to go into the future with a forecast. And the orange line continues this same cycle. As you could see, this kind of, it really kind of seemed like it learned that pattern, that seasonal pattern that was occurring throughout the historical data of the time series. And then it projected that into the future, right, with this bit right here. Not only did it project the seasonal component into the future or extrapolate it into the future, but you can also see that the trend, this upward trend, also continued as it did up to 2015. So now, the year 2015 itself continues to see growth, an upward trend, and still has this within year cycle, which we call seasonality. So this is the power of the classical multiplicative model and decomposition models in general. They take apart time series value and learn about the different components, seasonality, trend, cyclicality, and then project those into the future. Okay, there are a couple measurements that people use to kind of judge how well a forecast is done, especially if there are a couple choices of forecasting tools. One of them I'll look at here very quickly is mean squared error, and we get this by basically let me just talk about this. We'll basically just see the difference between each of these guys, the actual values and the predicted values, and we're going to look at the difference. So 4.8 minus 4.89. Okay. 4.8 minus 4.89, and then we'd square that difference. Okay, and we do that for each row all the way up to, obviously we can't go past the time period 16 because we don't have actual values to compare to for the future. So we would do that for each of the time periods, and then we would square those differences and then divide that by 16. So actually, you know what, we could do this just so this is a little extra. This is kind of an assessment tool, so we can kind of judge how well things went, in addition to the plots themselves. Okay, so this plot is beautiful. Looks like things worked out very well. Let's also use this more analytic tool. So here we're going to do y minus y hat, and y hat is obviously for me means predicted y. Okay, so equals this guy minus this guy, and I should have put parentheses because I'm going to square that difference. I'm going to do that for all the periods that I had actual values for. Okay, that's way too many decimal places for me to look at. Then I'm going to sum this, so I'll kind of pull that over here. So MSE is going to do a sum of these squared differences that we just calculated. Okay, and then I'm dividing that by how many of these there are, how many time periods there were. Well, there were 16, right? That's easy to see. There were 16. Okay, and that is a number that gives us a measurement of how well things went. It's a number that you would want to perhaps compare to another model that you create to try to forecast things. Remember, the classical multiplicative model that we just used is one of many, many choices of models, structural ways to do forecasts. So perhaps you want to try a slightly different method to make forecasts and then compare how well those two methods worked. Well, this would be one tool that's available to you. You can compare the mean squared error from this model, all this work that we just did in this sequence of tutorials, and compare that to the mean squared error of the second model that you create, second forecasting model that you create, and you can kind of see which one's doing a better job. Okay, so I just wanted to also give you this kind of post hoc analytic tool as well. All right, so I hope this was all helpful. Remember, you had to watch these videos in sequence. They all built on the previous. So classical multiplicative model with seasonality and trend. So till next time, have a great day. Excuse me, I should add, if you want to see how to do this exact thing in Microsoft Excel, it's not too different. I do have a tutorial series which is 3 parts that deals with this same exact data set but done in Microsoft Excel, whereas this was in Google Sheets. Okay, so both of these tools will give you the same results. You should get the same values, you should see the same results, same plots, just slightly different perhaps tools along the way to get there. Alright, so I just wanted to also mention that. So look for that in the links below in the information on this video, and you can learn how to do that in Excel. So now, have a great day.